The next book is a book on the abacus by Jesse Dilson, the world's first computing system, where it comes from, how it works, and how to use it to perform mathematical feats, great and small. As the book says, this is all about the abacus, one of the very first computing devices, long before the slide rule, or long before the computer. So this book is all about this and basically how it works and how to compute things, basically everything about the abacus. So the chapters are 10 is a round number, the ancients, the moderns, oriental know-how, reckoning on the rack, electrified abbacy, venture into the mystic east, math in the mystic east, where things get rough, and the private lives of numbers. Extremely cool book, especially if you have some young students who, basically, let's say 13, 14 years old, who wants to get, who really likes math. I think this is a pretty cool book to really learn, to really look at. The writing is pretty nice, it's pretty calm, but you still learn quite a lot from it, especially how things were done in the past. So yeah, definitely a very cool book. I guess anybody on the server can read it like in a day or something, but still it's fun. Then we have the book on the Middle East, The Cradle of Civilization by Dr. Stephen Borg, and it's all about the Mesopotamian era and of Mesopotamians. So they basically talk about introducing the Middle East, the Fertile Crescent, birthplace of agriculture, Mesopotamia, the cradle of civilization, power struggles, kingdoms at war, masters of the known world, the age of empires, under occupation, Hellenistic and Roman conquerors, and search for origins, the rediscovery of the Middle East. So it basically talks about the Middle East, and it goes from the beginning to the very end, well, the end of the ancient Middle East at least. And it talks about all the developments in art, in pottery, in culture. It talks about the cultures, the writing system, the rise of Lagash, city-states, beyond Babylon, Semitic migration. So extremely good book that I got at the Louvre in Paris. I really like this book. I really like reading it. Excellent book. Next we have a book by Kirsty Anderson, The Geometry of an Art, The History of Mathematical Theory of Perspective from Alberti to Monge. So it's all about projective geometry, the invention of projective geometry, of perspective geometry. It is an introduction, acknowledgements, notes to the readers. Then they go to the birth of perspective, Alberti and Piero della Francesca. Then we have Leonardo da Vinci, of course, has to make an appearance. Italy in the Cinquecento, north of the Alps before 1600s, the birth of the mathematical theory of perspective, Guibaldo and Stephen. Then the Dutch development after Stephen. They talk about Italy after the Guidobaldo, France and the southern Netherlands after 1600s, Britain, the German-speaking areas after 1600s, Lambert, Monge, closing the circle and summing up, and then some appendices on ancient roots of perspective, the appearance of a rectangle in Leonardo da Vinci, Schravesandus taking recourse to the infinitesimal calculus to draw a column base in perspective, and the perspective sources listed country-wise in chronological order. So it's all about history. It's all about the history of a very specific type of math, the math of perspective, and it was basically done by artists. It was basically invented by artists to be able to make realistic paintings. But it was still, and it still is, a very good part of math, like algebraic geometry, still deals with projective geometry head on. And it all comes from this. It all comes from making good paintings, nice paintings. So a very cool book here. Not easy to find. But yeah, I really love books like this, which really show the origins of mathematics, mathematics in art here. Yeah. Then we have a book, Relativity, by Hans Stefani, an introduction to special and general relativity. So it starts off with special relativity and immediately goes towards Minkowski space. Then it goes on against electrodynamics, transformation properties, pole-dipole particles and their field, and so on. Then goes to Riemannian geometry, introduces Riemannian geometry, introduces curvature, covariant derivative, differential operators. Then it goes to foundations of Einstein's theory of gravitation. And then linearized theory of gravitation of far fields and gravitational waves, invariant characterization of exact solutions, gravitational collapse and black holes, and then finally it deals with some cosmology. I bought this book because I think their introduction of the math and the math they use, differential geometry math, is particularly nice, is particularly insightful. I do think we need to do something like more beforehand, because I think it's still the best book of introducing the math. But this does it pretty well too. Amazingly good book, which I think really deals with things intuitively and in a way that I really personally like. Next we have here a little book, a very old book. What is it? It is Mécanique Céleste by Bovdic. And this book, a very old book, is basically about celestial mechanics, a memoir of celestial mechanics, and about Bowditch and how he got his ideas. Another very old book, well, this is not old, but when it was written it was old, Whittaker, a treatise on the analytic dynamics of particles and rigid bodies. The book, I don't know when the first edition of the book was, but I'm sure it was pretty old already. It was in 1904, and it deals basically with dynamics, and it teaches dynamics in a very, very different way than people teach it now. So we start with kinematic preliminaries, and we already see some topics which are very rarely covered nowadays, like Schall's theorem on the most general displacement of a rigid body, Halfand's theorem on the composition of two general displacements. So we see the Cayley-Klein parameters, we see Eulerian angles. These are not of, these are maybe sometimes covered, like Taylor does them a little bit, but yeah, here they really take to the forefront. Then we have the equation of motion. Then we see principle available for the integration, the soluble problems for particle dynamics, the dynamical specification of bodies, the soluble problems of rigid dynamics, theory of vibrations, non-holonomic systems, dissipative systems, the principle of least action and least curvature, Hamiltonian systems and their integral invariance, the transformation theory of dynamics, properties of the integrals of dynamical systems, the reduction of the problem of three bodies, the theorems of Bruns and Poincaré, the general theory of orbits, integration by series. Notice that this book, when it was written for the first time, at least the first edition, this was before relativity. This was before quantum mechanics. The first edition, at least. Later editions were quite during the quantum mechanics revolution. So, it's a very, very classical point of view of mechanics that books don't have anymore. You see, it teaches Lagrangians, it teaches Hamiltonians quite Yeah, quite. So you see that these people really had a very good command of Lagrange and Hamiltonians and all that stuff. And yeah, of course they didn't have computers, so they had to get every solution. Yeah, they have to get every solution analytically, and they can't like make a computer simulation of the orbits or anything. So yeah, that does place some constraints on things that we don't have anymore. Still, I really like books like these. So yeah, definitely one I'm happy to have. Here we see a book, Multivariate Analysis by Mardia, Kent, and Bibi. And it is a book on statistics, multivariable statistics. So it starts with basic properties of random vectors, normal distribution theory, estimation, hypothesis testing, multivariate regression analysis, econometrics, principal component analysis, vector analysis, canonical correlation analysis, discriminant analysis, multivariate analysis of variance, cluster analysis, multidimensional scaling, directional data, and then appendix on matrix algebra and univariate statistics. So yeah, I think this is my favorite book on multivariate statistics. It does some of the math, but not too profoundly. And it does give you quite a bit of intuition of where things come from and why things are the way they are. So yeah, definitely a very good book if you're into multivariate statistics and want to see a bit more rigorously what it is about. Definitely recommend this one. Here we see Topology and Analysis by Bos and Bleeker, the Atiyah-Singer's index formula and gauge theoretic physics. This is a book, of course, on the Atiyah-Singer formula. As you see, it's quite an old book. It's not even typed in LaTeX. So it starts with Fredholm operators, algebraic properties, operation of finite ranks, analytic methods, compact operators, the Fredholm alternative, the main theorems, families of invertible operators, Kuiper's theorem, families of Fredholm operators, index bundles, Fourier series and integrals, Wiener-Hopf operators. Then it goes towards analysis of manifolds, partial differential equations, differential operators on manifolds, pseudo-differential operators, Sobolev spaces, elliptic operators over closed manifolds, elliptic boundary value systems, elliptic differential operators in first order with boundary conditions, and then finally the Atiyah-Singer index formula, algebraic topology, index formula in the Euclidean case, index theorem for closed manifolds, and finally application. And then finally applications to gauge theoretic physics. So if you're good at analysis, at least if your main field is analysis, this I think is a particularly nice book of getting to the Atiyah-Singer index formula. So yeah, I have not read this book entirely yet. Maybe only first few chapters, but I still did really like what I saw. I think I probably need some more background to really appreciate a book like this. Next, we come to a book I really like. We see here Mathematical Structures of Quantum Mechanics by Strozzi, Mirror. This might be a book for you. Why? Because it deals with the quantum mechanics from a very beautiful point of view. It starts with C-star algebras. It starts with quantum dynamics, and it does everything basically from the point of view of C-star algebras and function analysis. It really tries to motivate C-star algebras. It really motivates the quantum mechanics, and it really shows how quantum mechanics is basically the same as classical mechanics, but non-commutative. Yeah, I really enjoyed this book a lot. This is a very, very, very good book. Deals exactly with the topics I like: quantum mechanics, lattices, function analysis, all that stuff. Very nice, very cool. Really love books like these, especially on these topics. Yeah, highly recommend it to anybody who's into the mathematics behind quantum mechanics.